Today's video, we're going to look at the Pythagorean Theorem and a little introduction to it. So, we're going to be solving problems like this. This is one example where I have a right triangle. I know what two of the sides are. I'm trying to find the third side. And many people come into high school having seen this already. Some people may not have. But there are a few things that often cause some problems I'm going to cover in this video. So we will be using the Pythagorean Theorem. And what the Pythagorean Theorem says is this. In a right triangle, has to be a right triangle. So I'm going to draw a little right triangle with a right angle there. With legs A and B. So the legs are the two shorter sides in the right triangle. They are also the sides that are adjacent to the right angle. And hypotenuse C. So the hypotenuse, that is the longest side in the right triangle. It is also the side that is across from the right angle. So in this situation, right triangle, the legs are A and B, hypotenuse is C, we get the equation A squared plus B squared equals C squared. Now, I will make a video for a proof of why this is the case. If you really want to know a reason behind why this has to be true, you can go watch that video. There will be a link in the description. However, for pretty much any high school level purpose, you can get by just knowing that you need to apply this, not necessarily knowing why or seeing a proof for why it has to be true. So let's use this and solve that example we just saw. So find the value of x in the triangle below. The first thing I'm always going to do is figure out which side is C. So in this case, across from our right angle here tells me that this x will be C. Now, once I have C figured out, it doesn't matter whether 3 is A, 4 is B, or 4 is A and 3 is B. They'll give me the same answer. So I'll just put an A here, I'll put a B here, but that doesn't matter. And now I will use the Pythagorean Theorem. Pythagorean Theorem was A squared plus B squared equals C squared. My A's are 3 and 4, so I will have 3 squared plus 4 squared. And the important one to note is my C is x. So I have an x squared over here. So I need to make sure that this one is the one that's by itself. And then I just go through and do the work. 3 squared is 9. This is relatively easy, but if I get large numbers, I could always use my calculator, either do 3 squared, so this does have a squared button on it. 3 squared just means 3 times 3. If I have a bigger calculator, I can use that, but this would be similar to a cell phone style calculator. So I will get 3 squared is 9. 4 squared is 16. And then I will just solve it. So the x squared is over here on the right. I have 9 plus 16 on the left. 9 plus 16 is 25. And to get rid of the squared, I'm going to do a square root. The square root of 25 is just 5, so x will equal 5. Now, one more note on this before we talk about some common mistakes. Algebraically, when I do this work, if you remember solving quadratic equations, I should get plus or minus 5, two different answers. But since I'm dealing with the length of a side, I'm only going to take the positive number. So that's why I'm just getting a positive 5 here. Okay, so what do I see that goes wrong? first thing is just sort of a carelessness mistake that I see way too often, people forgetting to square the terms. So I see in a problem like this, people writing down 3 plus 4 equals c, and just getting c equals 7. Don't do this. I need to make sure that I square every term. Also be careful, I might sometimes see 3 squared plus 4 squared, but this one, they forget a squared there. So be careful, this is not correct. Second problem, and it's not going to be an obvious problem in this example, but it will become obvious because one of the next two examples is going to set up differently, but not identifying c. So we know that 3 squared plus 4 squared is x squared, but sometimes people might mix up the order and try to say, okay, 3 squared plus x squared equals 4 squared. Now, this is not wrong because I can't have an x here. This is wrong because the x is across the right angle, and so it should be on this side. We'll see some cases where the x's could be these numbers. So be careful, make sure you correctly line up which side is c. And then the final error that I see showing up, or the final mistake, is including an extra square root in your answer. And again, this won't be too obvious yet, but in the next video, you'll see some cases where it will show up. So what I'm saying is sometimes students will go through, do all this work, take the square root of 25, and say, okay, my answer is then the square root of 5. Well, that's wrong. The square root of 25 is just 5. I have evaluated the square root. I no longer have a square root. So those are common mistakes I've seen. Okay, let's see a couple of examples and make sure this makes sense. So in here, find the value of x. I start off by identifying c. So I look for the right angle and go across the right angle. Don't just say c is the slanted side. The two things you're looking for is either across from the right angle or the longest side in a right triangle. So that's how I know what c is. Once I've identified c, a and b don't matter. The order doesn't matter. So I'll write out 30 squared plus 16 squared equals x squared. Now these are large enough that most of us might want a calculator to make sure we're doing it correctly. So 30 squared is 30 times 30. That gives me 900. 16 squared, again, some of you may know, but if you don't, 16 times 16, 256. Now I'm going to add these together, and again, many of you can probably get 1156 right away, but if not, go to the calculator, do 900 plus 256, 1156. That's a 55, there's a 56. And then, to solve this, take the square root of both sides. The square root of 1156, so I have a square root button here. If you're using a cell phone calculator, many times you can switch the mode into scientific calculator, and then you see sine, cosine, tangent, some really useful stuff. And you might need to turn it sideways. You might have to unlock the screen so it can go sideways. But I'll take the square root, and I get 34. Now, before I go into the last example, another thing to address. We're seeing a lot of nice answers here. The reason I'm seeing all these nice answers is, for now, I'm only dealing with what are called Pythagorean triples, which are 3 integers, I guess positive integers, whole numbers, that form the sides of a right triangle. So in many cases, when you take a square root, you'll get a decimal. We'll deal with that in the next video. But for now, I am dealing with what are called Pythagorean triples. 16, 30, 34 is one example of it. Or a previous problem, 3, 4, 5 is an example of Pythagorean triple. So don't think they always have to be nice values. For this video, for the attached worksheet, they will be, but in many cases they're not. Alright, last example for this video, and this is the case I was talking about earlier. I find which side is C, and notice when I go to my right angle and go across my triangle, it's not x here, it's 17. So 17 should be the one that's by itself in this C squared section. A and B, doesn't matter what order, I could do x squared plus 15 squared or 15 squared plus x squared. And now I need to solve this, so x squared I'll just bring down. 15 squared, you may know it, or you can go to the calculator, do 15 times 15, and get 225. Similar issue for 7 squared, you may know, I believe 289, but I can check. 17 times 17, 289. And now, since x squared isn't on the side by itself, I need to do a little bit more algebra. I need to actually subtract the 225 from both sides. So I'll do 289 minus 225. Again, you may be able to do that, you may not. That gives me 64. And then I'll do the square root of both sides. Again, you can go to the calculator if you need to. You probably know square root of 64 is 8. And we get x equals 8. So just be careful. The biggest mistake I see for students when they start dealing with this is they are so used to always finding the hypotenuse that once you move the x or the unknown to one of the other sides, they no longer are getting correct answers. Okay, there will be a video with the proof. There will also be a video in the description that has 6 more examples so you can see a bunch of problems just solved to make sure you're doing them correctly.